acid and base. So Arrhenius, he defined acid. He said acids produce H plus ions in solution, and he defined bases. He said bases, I need you to come and have a seat here. Bases produces OH minus ion in solution. So he defined acid and bases. Now then, Bronsted-Lowry, he said acids, he defined acid and base. He said acids are proton donor. Proton, you know the proton is H plus. H plus donors, and bases are proton acceptors. And let's see, for this example, HCl, H2O, which is in equilibrium with Cl minus 1 and H3O plus. Now you can see the HCl, in this one, these H plus go and join with H2O. So that means this is acid according to Bronsted-Lowry, and this one is a proton acceptor, so we can say it's base. Now we are going to define conjugate acid and base. So let's see in our next slide. Let's say acid in a water, or let's say HA is a acid in a water, H2O liquid, which is in equilibrium, H3O plus aqueous, and A minus 1 aqueous. Now you can see HA is acid, this is base, this is conjugate acid, this is conjugate base. Conjugate base. So now let's define what is conjugate acid and what is conjugate base. So let's see about conjugate base. Conjugate base is everything that remains of the acid molecule after a proton is lost. So that's the conjugate base, because whatever is the remain after proton lost, that's conjugate base. Now, conjugate acid. Conjugate acid is formed when the proton is transferred to the base. So that way you can identify conjugate acid and conjugate base. Okay. Now we are going to define strong acid and weak acid. Strong acid it ionization equilibrium it lies far to the right and it yields a weak conjugate base. Weak acid ionization equilibrium it lies far to the left and weaker the acid stronger its conjugate base. Conjugate base. So you can see if it is a strong acid, then it produces weak conjugate base, and if it is a weak acid, so it's a vice versa, it's produce strong conjugate base. So it's